Little Miss Alex has been lying down for hours on end, doing absolutely nothing. What a perfect time to measure her resting heart rate and determine the baseline of her cardiovascular fitness. But how? This fun machine over here is called an echocardiogram, or more simply put an ECG, and it records the electrical signals that pass through your heart and causes it to beat. In order for it to work, Alex must be connected to the ECG through conductor pads and electrodes. Once she is all good to go, we can begin to record the electrical signals. But first, a little bit of information on these signals would be beneficial. So channel your inner Bill Nye. The heart's contraction first begins once a group of pacemaker cells found in the right atrium depolarizes. This group of cells is known as the sinoatrial node. When this occurs, calcium channels are opened, allowing for calcium 2+ to be transferred to other cells in the heart. This transfer can occur as cardiac cells are connected by gap junctions, known as intercalated discs, that allow for the ions found in the calcium to flow from one cell to another. With the presence of calcium 2+ ions, the ECG is able to detect this electrical charge as it passes through the different parts of the heart. So, let's zoom in on a single beat so you can understand what exactly is happening with these signals as they pass through the heart. This first little hump, known as the P wave, represents the sinoatrial node signaling, causing the electrical signal to travel through both atria. With this electrical activity, the atria simultaneously contract, pushing blood into the ventricles. There is then a brief delay, as indicated by the flat segment. This delay allows for the ventricles to fill with blood so that when the atrioventricular node, another pacemaker cell, depolarizes, causing the ventricles to contract and the largest volume of blood to be pumped, this depolarization and resulting contraction are represented by the spike, known as the QRS wave. This wave is followed by the T wave, which indicates that the ventricles are repolarizing. The atria repolarize as well, however. This signal does not appear on an ECG as it occurs at the same time as ventricular depolarization, which has a stronger signal. With this knowledge we can determine Alex's resting heart rate. If we can determine how long one heartbeat takes on average, we can then calculate beats per minute. By multiplying this result by 60, we were able to determine that Alex's resting heart rate was 103.63 bpm.